Hi everyone. This lecture is in continuation with the previous lectures on the history of radio or wireless communications. In the previous lecture, we stopped at a point where the scientist Edwin Armstrong showed categorically that frequency modulation is a superior way of transmitting information than amplitude modulation. He showed that in frequency modulation, there was no problem of the static noise which existed in amplitude modulation. And we discussed that he was given some space in the Empire State Building where the office of RCA was now located, and he was working on this problem of FM radio. But by then, David Sarnoff, who was now heading RCA, had his interests and eyes set on a different invention, an invention which will add sight to sound. Because radio, by then RCO owned most of the radios in the country, and radio was an entertaining device, and the mode of entertainment was through sound. Now, here there was a new vision for a new entertaining device which will add sight to the sound, and that is the television. Now, the idea of television, in fact, at that time, by now, once radio became successful, they knew that the next form of entertainment it's going to be based on an audio-visual output. So many scientists were working on it, but the idea is often credited to a 15-year-old farm boy in America by the name Philo Farnsworth. He had this brilliant idea. He thought that if he can project an image which is formed by scanning the screen from one end to the other end of the screen. Now, if this scanning is done so fast that for a normal human eye it would look like a continuous image. He thought of this idea as a 15-year-old and immediately showed it to his physics teacher, who actually saw the value in it, and actually he had this idea and the physics teacher took that piece of paper with him. But it actually took nearly 10 years, a decade, for Philo Farnsworth to realize his idea as a teenager. And in his mid-20s, finally, he was successfully, after solving many engineering problems in it, this is the first generation television, so it operated on the principle of very much like a cathode ray, the cathode ray desktops. At least some of you might have seen it, where they would shoot electrons on a phosphorescent screen, and the movement of the electrons were controlled by horizontal and vertical electric and magnetic fields. Now, what he did was he actually, after successfully building a television, he showed this famous dollar sign on screen. And the venture capitalists who saw that for the first time were stunned, and they said that this man is going to astonish the world someday. But now, David Sarnoff has his eyes set on television. Now, he wanted to build a better world, but he wanted to build it himself. He did not want to live in a world where someone else made it a better place. So what he did was that he now had the power and the means. So he assembled a team of engineers to build a television from the RCA. He not only did that, but he also stalled the progress of Farnsworth to make it now that Farnsworth had the capital. He started manufacturing the television, but he stalled Farnsworth's progress by cutting off his raw materials, because by now by not cutting off, but at least he slowed down. Sarnoff was a very influential, and so he could do all of this. Finally, David Sarnoff was able to build it after, of course, the engineers of David Sarnoff took a longer time to solve it, but since he was able to stall Philo Farnsworth, he was somehow able to finish it before Philo Farnsworth could finish it. And what he did was he famously made this announcement in the public saying, finally, we have added sight to sound. And Philo Farnsworth's dream was destroyed. So what he did was he actually filed a lawsuit against David Sarnoff. And this lawsuit attracted the attention of the media because here was a small farm boy who had this great idea, and he was going up against one of the most powerful men in the country. And it was almost like a David and a Goliath fight. And in fact, in the court case, Philo Farnsworth's teacher, who was a teacher when he was in his high school, he came to the court with a paper containing the sketch of Philo Farnsworth drawn many years ago. And it was a very emotional moment. And when he actually showed that this idea that Philo Farnsworth thought of was actually dated back to a very long time back when he was a teenager. And in fact, interestingly, the idea that David Sonoff's team had finally cracked looked very similar to that idea. And finally, the court ruled in favor of Philo Farnsworth. But unfortunately, luck was not on his side. Even though he won the case, he couldn't reap the benefits or the money from the television's inventions because World War II was about to happen. Now, before I start discussing World War II, I'll also discuss the intellectual climate and the problems that engineers were solving around that time. Around that time, Bell Labs had now become a behemoth in the communication industry, the communication field, and they were actually now the leading telephone manufacturers in the country. But Bell Labs had one major problem is that the invention of vacuum tube amplifiers enabled long distance telephoning. They were able to successfully build long distance telephone lines with the help of the vacuum tube amplifier. So, one problem was, which I have already discussed in the previous lectures, is that the audio signals would decay as they traverse across a line, electrical line. So, they needed to be boosted. So, these amplifiers were called repeater amplifiers. And these vacuum tube amplifiers were used as these repeater amplifiers. But these vacuum tube amplifiers, they were quite bulky, and because the fundamental operation of vacuum tube amplifiers was very similar to that of an electric bulb, where you heat a coil and the coil emits electrons and then you control the flow of electrons using a third terminal. So its operation was very similar to that of, at least the heating part was similar to that of a bulb, so it would eventually burn out. And they had to constantly replace them, and that was a very troublesome thing. So they needed a better amplifying device. So this was one problem that was in the mind of some of the best engineers of Bell Labs. The other problem is there a fundamental better way of communicating information? So as the signal was traversing across this chain of buffers or repeater amplifiers, the amplifiers not only amplified the signal, it was also amplifying noise. And of course, every amplifier will also add its own noise, which was getting amplified by the next stages. So is there a better way of conveying and transmitting information? So that was another problem engineers of that time were working on. But as war came into its full swing, all the best minds, the engineers, the mathematicians, and physicists were all put for war work. Now, around the same time, in fact, in Europe, there was a young rejected artist who eventually rose to political power by using the widespread unhappiness and the widespread dejection in the public after the economic depression and the World War I, and he demonized two communities, especially the Jews and the socialists, and he rose to power. And eventually, the horrors that he had actually carried out in 1930s will become visible after the World War II in 1940s. And he was rising to power, and the whole world feared the rise of fascism in the Central Europe. Around the same time, across the other end of the world, in India, the whole nation was fighting against the British Empire. They were fighting for their independence from the British Empire. Now, this was the first time a non-violent struggle was managed in such a large scale against an empire that I'm just saying even the guns, grenades, and the firing cannons couldn't stand against it. It was not a war waged by ammunition, but it was a war waged by a non-violent resistance. So 1940s is a very interesting time. So on one side we had some of the best inventions of scientific history. So we had the development of the atomic bomb. We had the development of the weapons program at such a large scale. And also towards the end of 1940s, transistor was invented, and also we had the mathematical theory of communications. So 1940s, it's a very interesting decade. So as all the finest minds were now put to war's work, the problems that I was talking about a few moments ago were put on hold. In fact, Second World War was famously called as the War of the Scientists. So you had some of the best mathematicians, engineers, and scientists working for war's work. Now, this is where the other interesting character that when I was beginning this history of radio frequency or wireless communications, I was talking about another interesting character comes into the play. His name is Alan Turing. Now, England, before as World War II was going on, England was completely choked on its seaports by the German submarines. And once the seaports are choked, the exports are also choked. The exports are also stopped entering into the country. And that was a big problem for the British. In fact, not only that, Hitler was also raining terror from the skies. Now, for the British to win the war, they needed to somehow stop the seaport choking by the Germans. The Germans used to use, in fact, all the best technological use was put to use in the war work. The Germans were wirelessly transmitting information from Germany to the submarines in the Atlantic. Now, these messages were encrypted messages. So these messages were not just direct messages transmitted as it is, they were encrypted and then transmitted. And for the encrypting, the Germans were using an encrypting device called the Enigma. And Alan Turing will go on to be the man who cracks the Enigma code. He was as a young student in England, he was interested in physics and mathematics, and like most of the students who are interested in physics and mathematics or in the fields of engineering, landed up in America to do his PhD in 1930s at Princeton. Once he finished his PhD, then he went back to England and he started his work on the Enigma problem. Again, some of the best minds, all the scientists were put to war's work. So he was also doing this work, and he was also put on this work of cracking the Enigma code. There, after he successfully cracked the Enigma code, in a way it helped the British to win the war. So this war is war won by scientists. Oftentimes in history, it's recorded that way. Now, just to mention a very interesting trivia, since we were talking about the secret communications. So this was the age of not just transmitting information, but just also encoding the information so that only the intended receiver receives that information. A very interesting trivia is about the scientist Heidi Lamar. Heidi Lamar was actually married to an ammunition manufacturer in Australia. She escaped the marriage, she ran away, and she landed in Paris. And there she was spotted by a Hollywood producer, and then eventually she goes on to become a Hollywood actress. Now, she always believed in a scientific thought. In fact, she famously said, anyone can look pretty, all you need to do is stand still and look stupid. Now, she, along with a musician, came up with a very interesting idea for fooling the receivers. For example, if you know the carrier frequency which is used for modulating your message, which is used for transmitting the message, then you can, with appropriate tuning filters, you can actually decode or receive the message. But if you can somehow not let the receiver think or know the carrier frequency a priori by randomly varying it with time, then the signal, instead of looking like a narrowband signal like this, that the RF signal which is transmitted, it's now going to look like a wideband signal this way. So it's going to look like noise to an unintended receiver. So if the transmitter and receiver knows the code by which they are randomly picking this carrier frequency, then you can have a safe and a secure communication between the intended transmitter and the intended receiver. Heidi Lamar thought of this interesting idea along with the musician and the patent, which would probably today be referred to as frequency hop spectrum. and it is used still in some wireless standards. Now I'll come back to the story of Alan Turing. So after cracking this Enigma code, the World War II, Alan Turing had finally reached his place. He had reached his peak of fame, and the World War II had also ended. And back to our story on radio communications, Edwin Armstrong is now back to working on FM radios, and the World War II has just ended, so now he is back to building FM radios. Now, if you see both these men, on one side you had Edwin Armstrong, on the other side you had Alan Turing. Both of their work. In fact, I'm just mentioning only these two scientists because for this story, for the sake of continuity, I picked the work of these two scientists, but there were many other engineers and scientists who contributed to the war work. But the contribution of Edwin Armstrong was more on the hardware side. His innovations made wireless transmission a reality. And whereas the contributions of Alan Turing was on the software side, the encryption part. In fact, the ideas of Alan Turing, even as an undergraduate, he was always interested about the machines that can think. What if the machines that they are building, the computing machines, can they think for themselves? In fact, that's why his ideas were foundational, which would eventually go on to contribute significantly to the fields of artificial intelligence and theoretical computer science. But as the war ended, new problems arose for both of them. In case of Edwin Armstrong, he knew FM radios are the future, so he was very strongly enforcing his view to DavidSONOFF that they should start manufacturing FM radios. But DavidSONOFF did not see it as a good business idea because there were already a lot of AM radios in production. So therefore, he immediately moved out of RCA and he wanted to manufacture his own FM radios and sell it. Meanwhile, Alan Turing, if any of you have followed the story of Alan Turing, since it has been made so many times, Alan Turing had a break-in his house, and so when he reports to the police, so they discover about a secret life of his, that he was in fact a homosexual. And in those days, this was before around the World War II, where many of the scientists, because this was the age of espionage and all of that, so many of the scientists had to go through security clearance before they were hired for the government's work. And at that time, Alan Turing was seen as a security risk by the British government. And so he was put under house arrest and some medication for his, in fact, it was very stupid now to think of it, but all of this was done at that time. Edwin Armstrong now was going against DavidSONOFF. Now when he was working for him, DavidSONOFF and he were very good friends. But now the moment he decided to go against DavidSONOFF came against him with the same weight that he went against Philo Farnsworth. So what DavidSONOFF did was that, in fact, what Edwin Armstrong wanted was that he was now manufacturing FM radios. And because a lot of customers had already purchased AM radios, if he had to convince the public to go for AM radios, FM radios, then he had to ensure that the tweaks that he had to make had to be less expensive and very simple. But for him to accomplish such minor adjustments, he needed the same bandwidth to be given for FM radios as it was for AM radios. But DavidSONOFF arm-twisted FCC, who were responsible for allotting the frequency spectrum. And he arm-twisted them and he argued against giving the same band for FM radios. Because he was sure that once the public start listening to FM radios, they will quickly switch over to that. And that would hurt his business. So he completely stalled the progress of Edwin Armstrong. And so Edwin Armstrong lost all of his savings in his lawsuits. And eventually he was driven to rage and near madness, and he fought with all his close friends and he distanced himself. In fact, he once injured his wife with a poker and she also left him. So he was now living in the hotels. So in fact, he famously said that they're going to stall his progress. When I say stall this, he's referring to his FM radios, until I'm dead or broke. Eventually, on a fateful day, he finally in 1954, he was fully dressed, that the way he normally does, and he jumped off his building to death finally, and tragically he ended his life in 1954. In fact, before he died, he wrote a letter. He wrote a note to his left a note to his wife saying, "May Lord have mercy upon my soul." Shown here is a newspaper clipping, which actually shows in print the message immediately after his death. He died in obscurity. Not, in fact, we will later see in a few moments later about the other events that happened. Unfortunately, even after all his great contributions, he ended his life tragically. And in the same year, a few months later, Alan Turing, because he could no longer take this house arrest and the way he was harassed by the government, and so he ate an apple laced with cyanide, and he also ended his life. Both these men who made significant contributions, one man made contributions for connecting the world, the other man made contributions for an intelligent world, where he believed that every man-made invention in the future will be intelligent and machines will be able to think. He set off a new era of, in fact, at a later stage, artificial intelligence would take off. And he laid the foundational works for theoretical computer science as well. But he also ended his life tragically, like Edwin Armstrong. Now finally, to complete the story, I'll come back to one of the other characters that we left off when we started with the history of radios, the story of radios, and that was DeForest. DeForest now was an aging scientist. Now he hired a PR agency. He was trying to convince the world that he was in fact the father of radio. If you recall, I had said that Edwin DeForest, even though he invented the vacuum tube amplifier by fluke, by just introducing a third terminal, he didn't really fully understand the operation itself. So he was now trying to convince the world that he was indeed the father of radio, and he was appearing on television shows, and he was being popularized as the father of radio. In fact, he sent a mail to a post office asking to send this mail back to the father of radio. But they didn't know who the father of radio was, so the mail was returned back to his own home. And not only that, he was also inspired to make some contributions to the government as well, and he built a guided missile system for the military. And when the army officers were experimenting, or who were seeing a trial of this guided missile system, when they fired the missile, instead of the missile hitting the target, it in fact flew back to them, and they all narrowly escaped death. So that was the story of DeForest towards the end of his life. And there was a very interesting quote by one of the engineers. They said that this was regarding Edwin Armstrong. 500 years from now, people may not remember who Sarnoff was, or maybe who DeForest was, but they will read the great papers written by Edwin Armstrong. In fact, Edwin Armstrong wrote 2 seminal papers, one of course on the functioning of the amplifier, other great paper on frequency modulation. Even today, that paper can be read, and it's a great work on proving why FM is a superior solution compared to AM. Now, Armstrong's wife takes his case and fights for his patents, and eventually wins all the cases. And if you recall, I said in the beginning of the story of radios, Armstrong bought a car which did not have AM radio because he hated static. Armstrong's wife, for the rest of her life, drove that car, and that's how this story of Armstrong ends in the history of radio. And finally, DavidSONOFF, who was by now one of the most influential men in America. He was a typical success story of an immigrant. He came as an immigrant with nothing to the United States, and he went on to become one of the most powerful and influential men in the country. And when he died, in fact, he was featured on Time magazine, and when he died in 1971, the entire nation mourned. So that's the story of radio, where we had 3 of the finest minds. And also I tied it to the story of Alan Turing, because it's not Alan Turing's story doesn't come in the path of communications, but his was more of a work for artificial intelligence. But that's where we are headed in the future, where every man made device will not only be able to communicate with every other device, but it will also be able to uh, think for itself. We will have intelligence built into it. So we are building a future intelligent and a connected world. And these are the men who made significant contributions to it. In the next part of the lecture, I'll talk about the digital revolution. And most of us are living or at least seen that revolution since our childhood. So I'll very quickly brush through that in the next lecture. Thank you.